Earthquakes. How and where earthquakes happen. Here are your learning goals. Describe the causes of earthquakes. Explain the difference between the focus and the epicenter. Explain how P waves and S waves differ. An earthquake is a shaking of the Earth's crust caused by a sudden release of energy. This energy is usually caused by a strain that builds up along faults at or near plate boundaries. Remember, in our plate tectonics unit, we learned that the majority of earthquakes occur at plate boundaries. And of course, faults, we learned in the last section, are breaks in the lithosphere, which the lithosphere is the crust in the asthenosphere, and movement occurs along these breaks. All right, so we need to learn a few terms when we're talking about earthquakes. The focus is the actual location where the movement occurs along the fault line. So the focus would be this area right here where movement has occurred along this fault. The epicenter is the point on the Earth's surface directly above focus. When we hear about earthquakes, we always hear that they're, say 40 miles east of Los Angeles. What they're talking about there is the epicenter, that spot on the Earth's surface directly above the location on the fault where movement has occurred. That's the epicenter. Earthquakes release their energy, and that causes waves to travel outward through the Earth. Some travel through the Earth, and we call those body waves. And there are waves that travel along the Earth's surface, and we call those surface waves. There are two types of body waves that we're going to talk about. The first one are called P waves. P waves are caused by compression. There's a P in compression, so P waves are caused by compression. All right, so if we compress and stretch rocks, waves will move out through the rock. P waves can move through any solid or liquid material, so they can move through rock, magma, liquid iron in the outer core of the Earth. They can move through water. A different type of body wave is called an S wave. S stands for shear. S in shear, S wave. Shear waves are caused by movement at right angles to the direction the wave travels. Shear waves can move only through solids, so they can only move through rock. They can't move through magma, they can't move through water, and they can't move through the outer liquid core. S waves also only travel about half the speed of P waves. They're much slower. So if we looked at this diagram, this would be what a P wave would look like. There would be a compression in the rock, and then it would stretch out. Compression, stretch out. Compression, stretch out. S waves, or shear waves, move at right angles to the direction of movement of the wave. All right, so we've talked about P waves and S waves. Those are body waves. There are also waves that move along the surface when there's an earthquake. They cause the Earth's surface to move up and down and side to side. You can think of them as a combination of P and S waves. That's not entirely correct, but it is an easy way to think about it. Surface waves are what cause the damage that we see from earthquakes. When we talk about earthquake damage, we're going to learn that it's not the up and down motion, but the side to side motion that's the most damaging. Now let's look at this diagram and apply some of the terms that we've learned. Here is where there's been movement along the fault and energy has been released. Now what do we call that? You're right, focus. And then this is a spot on the Earth's surface directly above the focus. We call that the epicenter. This would be the underground line of the fault. This would be the trace of the fault on the Earth's surface if it was visible. And these concentric circles would represent seismic waves moving out from the earthquake.